Okay, I just wanted to quickly, well, not quickly, this should take several minutes, demonstrate how you can import the point cloud data from a 3Shape PTA file and clean it up a little bit in Blender. And then remesh it in Meshlab and save it as whatever file type you want. I'll just import this example. It's a point cloud representing a single unit prep from a dental scanner. See, it comes in quite a bit noisy. There's these artifacts over here, and this is why I prefer to import it into Blender first. You could do the following operations in Meshlab, but they go a little faster in Blender. So quickly tab into edit mode, hit A to deselect everything, hit B to box select, select the part of the prep that you want. Make sure this little box is unchecked, otherwise if it's not, and I do this, and then I go to select my inverse, all the points that were behind the ones we selected. Let's see if we can show it. Well, no matter. But make sure this happens here. Okay, delete them. Tab back into object mode. And we'll move all that geometry to the origin. You can skip this step if you're doing multiple meshes and you don't want to destroy their relationship to each other. Don't just skip that step. It doesn't really matter. It's just easier for me because it's right here in the center. Okay, one optional step is we can kind of decimate the mesh a little bit by removing the doubles and then changing the merge threshold to like 50 microns, since that technically just averages out all the data points on a 50 micron scale. We could even do this on 100 micron scale and see that we still end up with something that looks pretty good, but I'll actually not do that at all and just stick with the raw point cloud. So back into object mode, select the mesh. We're going to export it as an object. And there are a lot of presets over here that are actually kind of a pain. Make sure you have to check selection only. If there are other objects in your scene, it will spit out the whole scene into one big mesh. Also, don't write the materials. And that's pretty much it. So here you can see I've played with it with a bunch of different settings for okay, now we'll come to Meshlab. We'll import that object that we just exported. Okay, and notice here that we're up here in point cloud mode. If we switch to these different wireframe modes, there's nothing there because there are no wires. The first thing we need to do is calculate the normals for each point to help out with the second filter that we're going to run. So compute normals for point sets. Here you'll need to play with this parameter to find the best one. I found that for the raw mesh, between 10 and 20 seem to be giving me good results. Smaller numbers will mean more noise, but sharper features will be maintained. Larger numbers will mean a smoother overall mesh, both in noise but also in features. So I'll go with 12. Okay, that's done. Now we'll come to the remeshing filters, and we'll do a Poisson surface reconstruction. Okay, if you hit the help, it gives you a little description of what these do. The higher this number is, the more computer power it takes and the more detailed your mesh will be. I found actually that 6 works pretty well. You might be able to step that up 1 or 2 more times and also increase this number, which should keep your computer from crashing but also make it take a little longer. Let's start with 6 and 6, see what happens. Maybe bump it up to 7 if you think you need the detail. This also may be something we need to experiment with later, because as I'll show back in Blender, there is a significant amount of noise in this point cloud, and so where we choose to place our mesh amongst that noise, we can cut through right through the middle of it, place it above it, or place it below it. Okay, so nothing looks like it's changed, but if you now switch to this view, you see that we have a pretty decent looking model. The margin's pretty rounded, so yeah, you may need to increase the depth of that octree as it's called, but for demonstration I'll just keep going. So now we're going to export this mesh just back into Blender, just to show, just so we can compare the original. From here you could go straight to STL and then into whatever different program you wanted to. So I think I called it this last time.